How's it going, everybody? In this video, we're going to go ahead and wrap up our VPC HA firewall deployment on 9K5, 9K6, Switch 6, ASA 11, and ASA 12 by finishing up the configuration on Switch 6 and then getting ASA 12 with a basic configuration so that we can go ahead and configure the HA configuration on the ASAs. So without any further ado, let's go ahead and dive into the config and just kind of verify where I'm at up to this point. So basically, if we were to look here, I've just logged into the switches, and you can see that I have the port channel here is good to go between the VPC is connected to switch 6, and on switch 6, if we were to come in here and do a show ether channel summary, we're going to see that the port channel is working, show interface trunk, and we're in good shape. Now we're going to go ahead and configure interface gig 0/3 with a switch port trunk and cap.1q switch port mode of trunk, and that's going to allow us to take that to the next step. Because if we do a show VLAN brief, we're not applying any VLANs to any ports at the moment, right? We are configuring the switch as a multi-point connection capability down to the ASAs. So we do show interface trunk. We now have, once gig 0/3 has converged, we'll be able to then jump down to the ASA and configure it with the necessary configurations. So should be just about there. Show spanning tree VLAN 10. Okay, there we go. Now it's good to go. So what we're going to go ahead and do is on the ASA, we have ASA 11 here. I'm going to come in here and I'm going to do a show interface IP brief, and we have some basic configuration in place. What I'm going to go and do is I am going to configure ASA 11 to be the, we're going to do stateful failover on the ASA. And what that basically means is the ASA will have its connection database consistently updated and things like that with new flows that are coming through the firewall. What's going to end up happening is we're going to configure ASA 11 to point control plane and data, its connection database will automatically be sent over the connection link, which is gig 0/1 between ASA 11 and ASA 12, so that any connection information that is actively going through ASA 11 will automatically be sent down to ASA 12. So in the event of a failover where, say, ASA 11 checks out, goes to lunch and doesn't come back, or powers off, whatever the case might be, ASA 12 has all of the up-to-date information. It's a way to keep the network working when you need it to work, and then have all of your connections fail and then go do additional information, have to reopen or reconnect to services that you had working. So to configure this, what we're going to go do is set up an active standby configuration. So on here, what I'm going to do is we're going to do this over a single interface, or what they commonly refer to as a same interface design, where we're going to use gig 0/1 between ASA 11 and ASA 12 as our connection. So on ASA 12, I'm going to come in here, go to global config, go to interface gig 0/1, and type in no shut, just so that we have it configured there. I am going to go back to ASA 11, and I'm going to begin configuring him the way that it needs to be. So I'm going to type in, the command is going to be failover, and we're going to say LAN interface, and what interface are we going to be using for the failover. So we're going to call this failover, and we're going to specify the interface. So it's going to be gig 0/1. Right now, gig 0/1 on this device is currently shut down. So if we do a show interface IP brief, we're going to go to interface gig 0/1 and there's no shut that. Do a show interface IP brief, and now the interface is up. We're also going to type in the failover, and this is where the stateful aspect of things comes into play. If we do a question mark, we do the link. This is where the link is going to say configure the interface and VLAN to be used as a link for stateful update information. So we type in link, and we're going to just give it a name. We're going to call this Stateful Failover, SFFO, and then we're going to define the interface. In this case here, we'll type in gig 0/1. It says interface already in use as a failover interface. So I can add an interface real quick to this. Let me go ahead and just do that real quick. I'll add in gig 0/2, or gig 0/3, excuse me. Fix that real quick. Okay, I'll pull this back up, and we're going to go hit the up arrow and gig 0/3. There we go. And then we're going to go to show interface IP brief, interface gig 0/3, no shut. Same thing on 12. Interface gig 0/3, no shut. And back on 11. Now that we have that, we're going to go ahead and say the failover. Let me go ahead and back out of this level. So failover interface, the IP that we're going to be assigning to this guy here will be for the failover interface. Failover will be 10.1 or 10.11.12.11/24. And we're to the standby IP will be 10.11.12.12. And then we're going to go ahead and say the failover interface IP for stateful failover. This one here will be, and I'll go ahead and just give it a simple one. This will be a 172. Actually, I'll do a 10.1.2.11. Do I want to use that IP because it's already being used in the backbone? Let me do a 172.16.12.11/24 to 172.16.12.12. Oh, I forgot to put it in standby. So let me put in the standby command real quick. There we go. So now that's in play. I'm going to go ahead and specify that the failover LAN unit is primary. Now I'm not going to do any configuration on the, I'm not going to turn failover on at the moment. I'm going to go ahead and come over here to ASA 12. I'm going to go ahead and type in the failover LAN interface. In this case here will be, we're going to go ahead and call this failover, and this one here will be gig 0/1, right? And then we're going to type in the failover interface IP, and for the failover interface, actually let's go ahead and say failover link. The word here is going to be called SFFO, and we're going to say this is gig 0/3, and we're going to go ahead and say the failover interface IP for failover will be 10.11.12.12/24, and then the standby address, or actually let's take that back, it's failover interface IP failover will be 10.11.12.11/24. It's going to be the same on both devices. And standby will be 10.11.12.12. And then the failover interface IP for SFFO will be 172.16.12.11/24. And the standby will be 172.16.12.12. And then this will be a failover LAN unit secondary. Okay. Now what I'm going to go ahead and do, now that we've defined all the config, we're going to go ahead and say that, make sure that all my interfaces are turned on at the moment, which they are. We're going to go ahead and type in failover. And on this one here, failover. Failover. So now that I've got that turned on, it's going to begin looking for a configuration here. So this will take a couple of seconds for it to do its thing. And we were able to take the failover is enabled, but standby IP address is not configured for this interface. Let's do a show interface IP brief. So we're good to go there. So all the config, if we do a show run, and we look at this output, it's going to be the same as ASA 11 is basically what's going to end up happening here. And so if I was to come over here to ASA 11 and jump out of global config and do a show failover, and if I wanted to look at anything specific, I could. But if we look at this configuration, we can see that we are using the failover interface. It's up, and we are sending some information across the wire and all that good stuff. Now this does take some time to synchronize and do its thing, because if you look over here, it says serial number, mate is unknown, stuff like that. This type of stuff does take some time to do its configuration and things like that. So what I mean by that is that when we're looking at the output information, we want to make sure that we're giving it adequate time to do its config push from the primary to the standby, even though we did get the notification, hey, the config has been pushed, right? But if we do a show failover, we can see that everything looks good, right? So we can't, I mean, you notice that we're clicking on ASA 12, but we're seeing ASA 11, because what's ended up happening is ASA 12 basically is just it's a standby device that's going to be there, and when something happens to ASA 11, ASA 12 will pick up for it. So everything's looking pretty good. Still getting a mate unknown for the serial number, but if we see that everything's looking pretty good for the most part, what I'm going to go ahead and do is I'm going to do a couple of quick ping tests. So for PC13, well, I'm going to go ahead and, as I was testing out in a previous video, I'm going to go ahead and ping 101.0.0.1 and see if I can reach it. And we're having a small problem with the deployment. So what I want to go do is on Nexus 9K1, let's go ahead and log into him real quick. Let's do a show BGP L2 VPN eVPN. Aha, there's nothing going on. So show IP interface brief. Our loopback is not working. So show run interface NVE1. We're going to go to interface NVE1. We're going to go ahead and flap the link. See if we can't trigger that. No, shut it. And show BGP L2 VPN eVPN summary. Oh, the peering is down. Okay, so that's a bigger issue. So let's see why the peering is down. So it's been down for quite some time, actually. So let's see if 5K is down too. Show BGP L2 VPN eVPN summary. Okay, so this side's up, which is good. And let's say the 6K is 9K3 is up, I should say. Failed to receive response from VPC peer 10. Ah, okay, that might be the problem. So, whoops, oh, that's right, I forgot a different password here. We're going to go ahead and do a show VPC. And okay, so that means switch 9 is not working. Let's see what's up with switch 9. Switch 9 is over here. And we can see that show ether channel summary. Okay, those are up and working. Well, we have a problem between the 9Ks. And that's what's happening here currently. So we may have to reboot. So if we do a show VPC, we may have to reboot this box. Peer link is down. Show interface status. Yeah, there's an issue with the VPC peer link, and on E1/6. So switch 8 is, let's do show ether channel summary. Aha. Okay, so we are waiting to be aggregated. Bunch of information being kicked back here. So we do have a problem with this box. And we are currently in the not in use, no aggregation. So in a situation like that, we're going to go ahead and copy, run, start. And I'm going to go ahead and do a write mem. Give that a couple seconds to do its thing. Save the config. And we can reload this box. But that's only affecting this guy. PC13 is not affected by that. But so let's go to PC14. Let's try to ping our gateway. So that's working. So PC13, there's some other things to troubleshoot over here. Nexus 9K1 looks like it might be down. So that's basically kind of what I'm getting from here, because if we look at 9K3 and do a show IP interface brief, 9K3 is working the way that it's supposed to be. So I'm going to do a copy, run, start on 9K1. And I'm going to go ahead and reload this particular switch because PC13 doesn't have connectivity, and when we look at the show IP interface brief, I had the loopback is down and the BGP peering is not working. Show IP route, I bet you the OSPF. Oh, okay, OSPF is working. But on 9K3, we can see everything is working the way that it's supposed to be. So that's more or less the problem that we're running into at the moment. ASA 12, okay, we're good to go there. So PC14 will be able to do the ping test. So I'll ping 101.0.0.1, and it's working. So, sort of. Well, that's good. At least it's consistently pinging now. So we go to the ASA and we do a show con long. We're going to see that there's a ping going out, right? That's what we really want to be able to see. So, and if we look at ASA 12, we do a show con long. And we go back to PC14 and we do another ping test. And click on 12, hit the up arrow. If we do a show failover, you should see that there is information. Let's go ahead and bring this down a little bit so we can see it. We can see that stateful object both transmit is good, which means that there is information going back and forth. So we go back over here to PC14 and I try to do a ping, and I do a count. So we'll do a count of, we'll do 100. So it should ping 100 times now. So we go back over to ASA 11. We do a show con long. We can for some reason it's not showing up here, but if we go up here to show failover, we can see that there is traffic being sent and received. So if we come over to show failover pipe include general, we can see that there is traffic being sent across the wire. So so the translation stuff, we can see that traffic is being sent across the wire, which is what we need. We need traffic being sent across the wire. Oh, I guess the count didn't trickle. Guess it might have already been done. I guess the count option doesn't work. Oh, maybe it's I'm not doing the right. -C, that's the problem. My fault. -C 100. So if it goes past 5, I know I'm on the right. There we go. So ASA 11. So I know it. There we go. We finally caught it. It finally took it a couple seconds for it to trigger. But we can see that happening. If we do the show failover, we should see that there is traffic being sent across, which means that the failover is tracking. So if we were to do a failover to ASA 12, that should work, right? So if we were to say failover active, because I believe PC14 is still pinging, and we're about a quarter of the way through. If I type in failover active, meaning make ASA 12 the active node, ASA 11 switching to standby, but if we do a show failover, we can see that it's going back and forth. Now PC14, the ping should still maintain. So active communication should still be allowed to go through the box. And if we go back to ASA 12 and look at the show con long, we may have to look on this box. We can see that the ASA 11, the traffic is still flowing through it, and it's failed over. So we're doing obviously a software-based test, but if we go back over to ASA 11 and say failover active, whoops, that's working as expected, right? Now here's a little trick that you can use on the ASAs if you need to use it. You can come up here and you can type in prompt, and you can type in host name. You can put in the priority and the state. And by looking at that, we are the primary and the active. And on this guy here, we are the secondary and we are standby. So we know that it's working the way that it's supposed to be because it's actively populating the traffic, and PC14 should be done. And then by failing back over, we had that one loss of that one ping. So everything's looking pretty good in terms of how all that stuff works. So we've gotten that done. So what I'm going to go ahead and do is in the meantime, I'm going to go ahead and I'm going to reload Nexus 9K1 and see if that fixes our problem. Yes, I do want to reboot the system. So we're going to be focusing more or less on the rest of other aspects of the network. So as far as I'm concerned, this test is now complete. We were able to validate things are working the way that they're supposed to be. Show VPC. We can see that everything's working here and we're operational. Our ping tests were good. We were able to flow through, do a failover. All that stuff was good to go. So until next time, guys, thanks so much for stopping by and hanging out with me, and I'll catch all of you in the next video.